When we look at the Big Dipper from Earth, we see a flat, cohesive shape. But if you could view those same stars side on, you'd find a group of suns with almost nothing to do with one another. To find stars that actually share a history, you have to look at a true cluster, like the Pleiades. In a cluster, the stars are born from the same cloud of gas and stay physically close to each other, bound together by gravity. Constellations, however, are an optical illusion. Their stars can be separated by hundreds of light years along our line of sight. They only appear perfectly aligned because we are viewing them from our specific coordinate in the galaxy. This also means that what we recognize as the Big Dipper isn't even a formal constellation. It's an asterism, a smaller, prominent pattern tucked inside the official, much larger boundary of Ursa Major. But if these patterns are just tricks of perspective, meaningless suns scattered across a deep void, we have to ask why almost every ancient civilization on Earth recorded them and used them to organize their world. The human brain is hardwired to find order in chaos. By connecting the random dots of the night sky into memorable shapes, early humans transformed the heavens into a functional instrument for survival. In the northern hemisphere, travelers used these patterns to find Polaris. By identifying the pointer stars at the edge of the Big Dipper, they could consistently locate true north over featureless terrain. In the south, where Polaris isn't visible, explorers relied on the Southern Cross. Tracking its distinct orientation allowed sailors to navigate across thousands of miles of open ocean. This model shows how the sky also functioned as a global clock. As the Earth moves through its orbit, our changing position causes different background constellations, the zodiac, to rise and set with the seasons. The arrival of a specific constellation acted as a celestial alarm. It told ancient farmers when the spring thaw was coming, when to plant their seeds, and when to prepare for the harvest. Long before the invention of magnetic compasses or mechanical clocks, drawing lines in the dark provided the primary infrastructure for human navigation and agriculture. Because the stars themselves lack any physical connection, they became a blank canvas. Isolated cultures looked at the same coordinates in the sky and projected their own values, fears, and legends onto them. Ancient China developed its own star maps entirely separate from the Western tradition. They organized the sky using 28 lunar mansions, creating a celestial system that prioritized timekeeping and astrology over the animal figures common in Europe. In contrast, Mediterranean and European cultures drew their localized folklore and mythical beasts directly onto the stars, populating the heavens with the heroes and monsters of their oral traditions. This led to a single region of sky holding dozens of identities. Where the Greeks saw a vain queen, the Shawnee people saw a group of dancing sisters, and in India, the same stars formed the shape of an antelope. This projection even extends to the black voids between the stars. In Incan and Australian Aboriginal traditions, the dark dust lanes of the Milky Way were treated as constellations themselves, revealing shapes like the emu in the sky. The night sky functioned as a global library, storing the memories and folklore of our species across thousands of years. During the Age of Exploration, European sailors began inventing new constellations to map the southern skies. As this map of Gemini shows, they began merging these older mythical figures with rigorous coordinate lines and mathematical grids. By the 20th century, this had created a logistical crisis for astronomers. The sky was a crowded, overlapping mess of different cultural maps, with no clear agreement on where one constellation ended and another began. In 1928, the International Astronomical Union stepped in to standardize the heavens. They commissioned astronomer Eugene Delport to divide the entire sky into exactly 88 officially recognized territories. In the modern system, the constellation exists as a contiguous geometric boundary. The illustrations of bears and hunters have been replaced by a rigid grid that covers every single square inch of the celestial sphere. These boundaries function exactly like state lines on a map. Any star, planet, or distant galaxy found within these coordinates is assigned to that specific constellation, giving astronomers a precise universal address system. But even these borders are temporary. Because stars move independently and the Earth's axis slowly wobbles, the shapes we recognize today will distort and eventually vanish over the next tens of thousands of years. We stripped the sky of its monsters and heroes to make room for precise science, but the 88 names remain, a record of how we drew lines across a chaotic 3D universe.